In today's video, we'll be going through my own predicted Paper 1 non-calculator exam. I've written this exam based on what I've seen from the trends, the patterns of particularly the Edexcel Paper 1 past papers. So this is just for your own revision. It's obviously not anything to rely on in the exam. This is not to say that these topics will come up in the exam or that other topics won't come up in the exam. So please make sure that you are checking out all my other videos to make sure that your revision is complete and not just solely based on this predicted paper. Question 1, work out 4.5 minus 2 2/3. Now you've got two ways to do this. You can subtract it whole numbers separately to the fractions. I prefer to just make them all into improper fractions and then subtract from there. So to make them into improper fractions, 4 times 2 is 8, add the remainder 1. That would be 9/2. Minus 2 times 3, which is 6, add the remainder 2, 8/3. So now I need to have a common denominator. Obviously the lowest common multiple of 2 and 3 would be 6. So changing both fractions, the first one timesing by 3, which is 27/6, and the second one by 2, which is 16/6. Now I can subtract the numerators. 27 minus 16 is obviously going to be 11/6. And now they have asked us to give it as a mixed number again, so 6 would go in once with 5 remaining. So 1 and 5/6 is left. Question 2 is now on decimals, so part A, work out 43.1 multiplied by 0.84. So I'm going to make these both into whole numbers. As you can see, the first one I would only have to multiply by 10 to make it 431. The second one, however, I would need to multiply by 100 to make it 84. Now I'm just going to set up my column multiplication. So starting off with 4, 4 times 1 is 4, 4 times 3 is 12, carry the 1. 4 times 4 is 16, plus 1 is 17. Going down to the 8, but because it's 80, I need to put a 0. 8 times 1 is 8. 8 times 3 is 24, carry the 2. 8 times 4 is 32, add 2 is 34. Now I can add them. So I get 4, 10, carry the 1. That would give me 12, again carry the 1, 6, 3. Now, obviously the answer is not 36,204 because I originally scaled up both my numbers. I now need to scale down. You can either do this by counting how many times you moved the decimal place and then just doing that in total. So here 1, 2 and 3, so 3 times back. You can do it by dividing by the 1000. 10 times 100 makes the 1000. Or you can almost figure out the scale based on 43 times by something less than 1 is probably going to be about 36. So moving my decimal place 3 times back, should have 36.204. Part B is now dividing decimals. In this case, I prefer to scale them both by the same amount. So, for example, the first one I have to scale by 100 to make it a whole number. The second one, I could technically just scale it by 10. However, if I scale it by the same amount, then my answer doesn't need to be changed at the end. So I'm going to do 735 divided by 250. You can do 25 if you want, that's up to you, but at the end you would have to figure out the scale. So 250 obviously doesn't go into any of them apart from 735. 250 multiples would be 500 or then 750, which is too much. So it only goes in twice. I already have to put some zeros. Now my remainder between 500 and 735 is 235. So then 250 into 2350. Well, 250 goes into 1000 4 times, so it would go into 2000 8 times and then plus 1. So that's 9 times with a remainder of 100 and another 0. How many times does 250 go into 1000? We literally just said that. We said 4. There's no remainder. Because I scaled both of my original decimals by the same amount, both by 100, in this case that would just be my answer. If you scaled yours by different amounts, you would have to then figure it out at the end. If you did 25, you would have got 29.4, so you would just have to scale it back by the difference between your original amounts that you scaled. For example, 10 and 100, the difference is 10. Question 3, find the highest common factor of 252 and 105. I prefer to do this by using product of prime factors, factor trees. That's just my choice. You can do it differently if you like. So half of that, I normally start with, if they're even numbers, I'll start with just 2 until it's no longer even. Then I might have a look at 3 or 5. In this case, 3 would work. 3 again, and then 7 is my last one. 105 is not even, so I'm going to start with 5, 21. Now I can do 3 and 7. Now I like to use the Venn diagram method to figure it out. So I just scribble 2 circles really quickly, and then the middle bit is the numbers they have in common. there is a pair of 3s and also a pair of 7s. That's the only thing in the middle. For highest common factor, you just need the middle. You don't technically have to fill out the rest, but you can if you want. Everything that's left goes on either the left or right sides. And then we just multiply everything that's in the middle for highest common factor. So that would be 21. Question 4. Kai is organising a charity bake sale. He bakes 120 cupcakes. He sells 3/5 of the cupcakes in the morning. In the afternoon, he sells 25% of the cupcakes he has left. And then the remaining cupcakes are shared between Emma, Connor, and Maria in the ratio 2:3:4. Work out how many cupcakes Maria receives. So I'm going to work out first of all 3/5. When we're working out a fraction of an amount, we just divide by the denominator, multiply by the numerator. Dividing by 5, I basically just divide by 10 and then double it. So dividing by 10 is 12, double it is 24. Times by 3, 20 times 3 is 60, 4 times 3 is 12, so that's 72. You can obviously use bus stop division and column multiplication if you prefer. So this is how many he sells in the morning. Now, it's then 25% of the cupcakes he has left that he sells in the afternoon. So I need to subtract the 72. When I subtract, I personally just prefer to add up. So that's 8, which would make 80, and then 40 to 120, so 48. 25% of that is the same as 1/4, so I'm just going to divide straight away by 4, which gives me 12. So he's sold 72 and 12 now. And then the remaining ones are shared. So of the remaining 48, I need to take away the 25% that he sold. You could also work out 3/4 that are left if you prefer. So we get 36. Now 36 is going to be shared in our ratio. We need to add up all the parts of the ratio. So that's 5 plus 4, which is 9. We're going to divide 36 by 9, which gives me 4. So that's 4 cakes per part of the ratio. Now we want to know just Maria. We don't need to work out the other two. So for Maria, she has 4 cakes per 4 parts. So 16. So your final answer should be 16. And as you can see, that is 4 marks. Question 5. Sadie wants to run 6 miles in 45 minutes to hit a new PB. Work out Sadie's average speed in order to achieve the PB. We must give our answer also in miles per hour. So I like to use my formula triangle. In this case, we're looking for speed. So that would be distance over time. Now, the other thing to consider is it's miles per hour. We need to make sure that our units in speed match up with our distance and our time. So the distance is already in miles, that's fine. However, the time is in minutes. So instead of 45, I need to know as a decimal or as a fraction how many hours that is. If you want to convert any minutes into hours, you always divide by 60, which as a fraction would simplify to 3/4. You obviously should also know 45 minutes is obviously 3/4 of an hour. So that's what I'm going to use. So in my calculation for speed, I'm going to do the 6 divided by the time, so distance divided by the time, which, because I've chosen to use fractions, is basically keep, flip, change, isn't it? So keep the first one, which is effectively 6/1 technically. Flip the second one and change it to a multiply. Do you see how I get 24/3, which is the same then as 8 miles per hour. Question 6. ABC is a right angled triangle. Work out the size of angle ABC. So that would be this angle here, A to B to C, this one over here. So because this is obviously going to be trig, SOH CAH TOA, I need to label the 2 sides that are relevant to me. Because we are finding an angle, the 2 sides relevant are obviously the ones that have already been given. So that would be the 7.5 is the adjacent, it's next to my angle. And then the 15 is more specifically the hypotenuse. So out of SOH CAH TOA, I need to use cos. So cos of the angle ABC is the adjacent divided by the hypotenuse. Now, in this case, 7.5, hopefully you recognise, is actually half of 15, so that simplifies to a half. Now, obviously we don't have a calculator, so we need to know how to do, effectively in your calculator you would do cos inverse. We can't do that here, so this is where you've got to remember those trig values from the table. Looking in your head in the cos column or cos row, which one was equivalent to a half? Hopefully you have it memorised. It would be 60 degrees. So that last bit you just need to convert yourself. Which cos value equals a half? Well, 60. Question 7. A to the power of 5 times a to the power of x is equal to a to the power of 3. Find the value of x. Now you could probably just work that out yourself, but if you wanted to know a more formal way of doing it, then our index law is adding the powers, isn't it? So that would be 5 plus x if I were to simplify it. And then because I've got just a to the power of something on one side, a to the power of something on the other side, technically those powers must be also equal. You can create an equation and solve it. If you want to do it that way so that you don't get anything mixed up, then that works. Otherwise, you might just be able to figure out that clearly the difference is -2. That's fine as well. Part B, write down the value of 18 to the power of 0. This is very common to have anything to the power of 0. It's always 1. Bit of a trick question. The answer is not 0. It is 1. And part C, find the value of 3 to the power of -4. So the negative power means reciprocal. The reciprocal of 3 is a third. And then you're applying the power of 4 as normal. So 1 to the power of 4 is obviously just 1. And I would recommend memorizing 3 to the power of 4. It's 81. It's the same as 9 squared. So 1 over 81 is your answer for part C. Question 8. The diagram shows triangle PQR. Triangle PRS, the smaller one, is an isosceles triangle. As you can see, we've been given the two sides that are equal. We've then been given a ratio for the size of angle PQS, so P to Q to S, so this one, to the size of angle QPS, so this one, they've said is 2 to 1. If you want to, you can label it in terms of x, or you can just leave it in terms of a ratio. So work out the size of angle PQS. So that's the 2x one, isn't it? Okay, we've only been given 63, so that's obviously where I'm going to start. Because this is an isosceles triangle, I know that the base two angles are equal, not the one at the top between the two equal sides. It's the base two here. Those are both 63. Now, because I know that this is 63, I can then work out, given that obviously QSR is a straight line, because I know that this whole thing is a triangle, I can work out PSQ. So PSQ, we'd have to do 180 minus 63. So take away 60 is 120, take away 3 is 117. That's 117. You also normally get marks if you label the diagram as well, so I find that handy. Now, I've got one angle in this triangle, but I have been told how to split the other two. So now I'm just going to be figuring out the other two. So angles, both of them, PQS and QPS, together would be 180 minus the third angle, 117. So we obviously already know that that's 63, don't we? So I need to share 63 between them. Now you can either just share it out in a ratio, or you can use that x that I figured out here, x plus 2x is 3x, and use an equation if you prefer to use algebra. That's fine. So x is 21. Now, the thing is, don't forget though that they did ask for PQS, which is the 2x. So I then need to do 2 times 21 to give me 42. So actually, the answer is not just the 21, right? It is 42. And that one we've been given 3 marks. Question 9. The price of a phone is reduced by 30% in a sale and now costs £294. Find the original price of the phone. So this is not only just percentages, but this is called reverse percentages because I need to go backwards in time. So I always try and figure out what percentage of the original price the 294 is in this case. If they've reduced the price by 30%, the original is always 100%. So obviously that would be the equivalent of 70% of the original price, isn't it? Think about it that way. Now, given that this is non-calculator, I obviously want to work out what 100% was. So the easiest way would be to figure out 10%. Now, it's not 10% of 294. It's 10% of the original price that I don't know. So the way that I get from 70% to 10% is divide by 7. Obviously, you can do this on both sides. So however you want to work out dividing by 7, I think I would do it with bus stop. So obviously into 24, it would go 4 times, remainder 1. Into 14, it goes twice, 42. They will tend to choose, fairly nice numbers. So 10% of the original price is £42. So how do I then work out 100% of the original price? Well, that's pretty obvious. I need to times by 10. Now, if this was a calculator, I would do it a different way. However, it's not on this paper, so that's the way I would recommend if you don't have a calculator. Work out 10% by dividing by whatever this value is in the front, and then multiply by 10 to get 100. So 420 is the answer. Okay, question 10. There are only 4 red counters and 3 blue counters in a bag. Taylor is going to take at random 2 counters from the bag. Then they've just said complete the probability tree. So that basically implies to me that they're not going to replace them. Taylor's going to take 1 and then the other, or just grab 2 at the same time. There's no mention of replacing the counter after the first one, is it? So just bear that in mind, that wording. If they haven't mentioned that they're going to replace it, you can assume that they didn't, that they just grabbed 2 at the same time. Imagine it like that. So I need to create probabilities for red and blue for the first and second counters. because they've given me actual just whole numbers and quantities of counters, I'm going to use fractions. You could use decimals if you want, but I feel like that would just be more complicated. So for red, I've got 4 chances out of 7 total counters in my first counter. For blue, I've got 3 chances out of 7. Obviously, these two must add up to 1, and the same with these two, and the same with these two. Now, following the red counter for the first one, imagine I've already picked a red one, and I'm not replacing it, so I've only got 3 red counters left, but also in my bag, I've only got 6 in total, so that's 3 out of 6 chances. Now, I didn't pick blue, so there's still 3 blue ones, but again out of 6, and that would add up to 1. Now down here, imagine my first counter was actually blue. I would still have all 4 of my red counters, but still out of 6, and I would have therefore only 2 blue counters out of 6, that also adds up to 1. So 2 marks for filling out the tree. Part B down here, work out the probability that Taylor picks at least 1 blue counter. Now there's 2 ways to do this. I realise in your exam you won't have highlighters, but I'm just going to demonstrate it with highlighters. If I were to highlight all the options that would satisfy picking at least 1 blue counter, I'll show you. I could pick the red one first, but then I'd have to pick the blue one second. That's one option. The other option is I could pick blue first, and then I could pick red second. Now the final option though, because it says at least 1 blue counter, so a minimum of 1, but it could also be 2 blue counters. I could also pick blue and blue. Now, you could obviously work out all 3 of those, that's what I'm going to do. However, if you have noticed, out of the 4 possible options, we've highlighted 3. So if you wanted to save yourself a bit of time, you could just work out red and red, which is the only option that it can't be, and take it away from 1 at the end, if you wanted to. I prefer to just keep things straightforward. So what we're going to do with probability trees is you always multiply between the branches because it's saying red and blue, blue and red, blue and blue. The AND rule in probability is multiply. So always multiply between your branches. So over here for red and blue, I'd get 12 out of 42. I realise that you can simplify that, but I wouldn't because it will make our next step a little bit easier. So 3 out of 7 times 4 out of 6, again 12 out of 42. And finally, blue and blue, 3 out of 7 times 2 out of 6 would be 6 out of 42. Now, as you can see, I've got 3 possibilities. Either the yellow one, the blue one, or the green one. Now, you can hear my language, I've said or. Whenever you've got an or situation, that means add. So the reason why I didn't want to simplify them is because they already have all got the same denominator. So when I add them, I just need to add the numerators. 12 plus 12 is 24, plus 6 is 30, which gives me 30 out of 42. So my answer is 30 out of 42. Now, for probability, they don't normally care if you simplify it or not. So you can simplify that if you want to, but they don't normally care. You see how in the question they haven't mentioned it. So I normally just leave it for probability. Question 11. So we've got here, describe fully the single transformation that maps triangle B onto triangle A. Just be really careful with these ones. Which direction? They're saying from B to A. I feel like naturally you want to go from A to B, don't you? But it's actually B to A, so just be really careful which way round they've said it. So, first of all, it's obviously got smaller in the first place, so that's clearly the type of transformation, first of all, is an enlargement, so that's kind of 1 mark. But then you'd have to mention some details. Obviously, it's 2 marks to the question. You can't just get 2 marks for writing enlargement. You need to have details about the enlargement. So what do we need to say about an enlargement? First of all, normally, the scale factor. Now, you can do that just by counting one of the sides. So, for example, the vertical side was 4. Now it's 2, so it's got smaller. It's basically been multiplied by a half, hasn't it? The other thing to consider, though, is you see how it's inverted itself? This is very common for higher tier. It's inverted itself. It's flipped upside down. So that's a negative enlargement. Not only has it got half as big, it's also flipped. So put the negative to make it flip. Now, the last thing we need to mention about an enlargement is the center of enlargement. And the way that I figure this out is just by drawing lines that connects all the corners. Now, just be careful that you do connect up the correct corners, because when it's inverted itself, you have to make sure that they're matching. So obviously this top corner for A matches the bottom corner for B. And then this bottom corner where the right angle basically would have been is the top corner on the left here for B. Now at this point you can kind of start to see where they're overlapping. And obviously then this corner goes to the last one on B. So you can see where they've all overlapped. That would be your center of enlargement. So make sure you write it obviously correctly. 0, minus 1 as coordinates. That would be enough details to get you all of the marks. Question 12, the table shows information about the profit made each day in a supermarket for 100 days. So we've got our frequency table here. Part A is to complete the cumulative frequency table. This is super easy, it's only 1 mark. You basically just add up all the numbers as you go. So for example, the first row will be exactly the same. The second row then includes the first 2 rows of the other table, so add 13. And then the third row includes another row, so add 34 to the 19, we get 53. And then add 25, so 78. You get the gist, add the 14, 92, and then add the 8. Your last row should, if they've mentioned in the question, add up to the total that they've given you. So that was 100, mine is also 100, so I know that it's correct. Now, if they tell you to fill out the table, the next part is normally to draw a cumulative frequency graph for this information. So obviously you'd be able to look at your table from either the same page or the page before in your actual exam, but I'm just going to paste it here so you can see it. When we're plotting cumulative frequency graphs, we need to know in terms of these ranges, where are we plotting? You have to remember it's always the right-hand side, the bigger end of the limits. So at 50, we can go to 6, so be careful of the scale as well. That's obviously 10 there, so it looks like 1 square represents 2. So I think 3 squares up for 6, 100 and then 19, so that'd be kind of halfway between that top square there. 150 and 53, 50's here, so 53 is about halfway there. 78 at 200, so that's just before 80. 92 here, and lastly, obviously 100. Your graph should be continually increasing. If it's not, something has gone wrong. Now I'm going to join it up as a curve the best I can. Make sure you do it with a pencil just in case it goes wrong and you miss a point, so you can go back and redo it, because then you are likely going to be using your graph to answer some more specific questions afterwards. So here you can see part C, use your graph to find an estimate for the interquartile range. So we want our graph to be ideally as accurate as possible. So interquartile range. The interquartile range, we should know, is the upper quartile minus the lower quartile to find that range. Now the upper quartile represents 75% of the cumulative frequency of the y-axis, and the lower quartile represents 25%. So our total was 100, so 75% of 100 is obviously 75, isn't it? So I'm going to draw a line across at 75. Just be careful of the scale again, it's not halfway here. That's 70 and then halfway again until it hits your curve, and then read off of the x-axis. So mine is about there. So again, be careful of that scale. I think every 2 squares is 10, so that's 160, 170, 180, 190, 192 maybe. You might get, again, you'll get something slightly different because obviously everyone's curve will be slightly different. So I've got, that's for the upper quartile. I'm going to say about 192. That's probably a bit too specific, but we'll go with that. And then the lower quartile is then 25% of 100, which is obviously, luckily, quite easy, 25. So halfway here across until you hit your curve and then down. I think that's about 112, 113-ish. So that's what I've got for my upper and lower quartile. Now, obviously, I do need to then subtract them to find the range. 192 minus 112 gives me an interquartile range of 80. They will give you a slight range of possible answers, just given that obviously your curve might be slightly different to someone else's. As long as you're within that range, then it's fine. As long as in this case you've got something that's kind of close to 80, that's fine. Now there is also a part D, so use your graph to also find an estimate for the percentage of days on which the profit was greater than 220. So this is now coming from the x-axis. So let's look at our graph again. We're now going from the x-axis because they told us something in terms of pounds. So 220 would be, that's 210, it'd be 4 squares along from 200. So this time I'm drawing my line up and then across to read off of my y-axis because that's in terms of the frequency. Now that's, I think, 82, 84, 85. So it's 85 here. However, they did say more than 220. 220 or more would be this part of the graph. Do you see how that wouldn't be 85? That would therefore be the difference between 85 and 100. So just be really careful if they've said more than or greater than or above. It's an extra little trick to make sure that you're actually reading the question properly. So 100 minus 85 would actually give me 15 days where it was greater than 220. But also, they want it as a percentage. So that's out of 15 out of how many days were there in total? There was 100 times 100. Now that's pretty obvious, right? You should get 15%. or something very close to 15 if your graph is slightly different to mine. Question 13. The straight line L has equation 2y minus 3x is equal to minus 8. The point A has coordinates 7 minus 1. Find the equation of the straight line that is perpendicular to L and passes through A. Okay, this is a really straightforward version of this question. I obviously can't find the gradient of the perpendicular line because I've only got one set of coordinates, so I therefore need to use and compare it to the gradient of line L. However, the equation of line L is not currently in the correct format, y equals mx plus c, so I can't just take the 3 and take that as my gradient, right? I need to rearrange this first to make y the subject. So obviously I'm going to add the 3x. I'm going to divide everything by 2, so that would be 3 over 2. I would recommend leaving it as a fraction. I know it is 1.5, but I would leave it as a fraction. And then minus 4, that bit doesn't really matter. So do you see how the gradient of line L is positive 3 over 2? So my gradient for the perpendicular line, this is where we do the negative reciprocal. I say keep it as a fraction because you're going to do the reciprocal. That's where you flip it upside down. Negative is where you just change the symbol. Currently it's positive, so it's going to become negative, or vice versa. So now I've got my gradient, so I can rewrite y equals mx plus c, but with my gradient minus 2 thirds x plus c. All I need to do now is find the plus c, the y-intercept. Now the only piece of information I haven't used is the coordinates that are on that line. So if I sub in a, just make sure you get it the right way around, minus 1 is y, and then 7 is x. Now again, we have to be really happy with fractions in this case. Multiplying a fraction and a whole number, you just multiply the numerator basically. So that would be minus 14 over 3. And then I'd need to move it across, so I need to add it. But the other side is minus 1, so we need to convert them to have the same denominator. 1 is the same as 3 over 3, isn't it, if you think about it? 3 divided by 3 is 1, so that would be the same. Plus, I'd have to add that one. 14 over 3. Now I can literally add them, just don't forget that this one over here is negative, so minus 3 plus 14 would be 11. And then obviously over 3, that doesn't simplify. So my last thing is just to write it as the whole equation, minus 2 thirds x plus 11 over 3. So there's my equation. Question 14, express 0.384 recurring as a fraction. So I always start by saying let, unless they've already done it in the question, let x equal to the decimal that they gave you. Now we need to get two versions of this equation, two versions of the decimal, where we isolate the recurring part. See how 3 is not recurring? I need to isolate it in the decimal and then move the 3 away, but also get two versions of that. So in this case, I need to get 10x because I need to move that decimal place once to get the 3 out of the way. So I've isolated the recurring part, but I also want another version of this. I need two equations. So I would actually need to move the decimal place twice to get the same recurring decimal again, wouldn't I? So that'd be times in by 100. So 10 times 100 is obviously 1000x. And then this one, just move the decimal place twice, is 384. And then do you see how I've still got the 0.84 recurring, again in the same order? So now I can subtract, obviously this side, 990x. The right hand side, the whole point is that it would cancel the decimals, that's why you want to get two versions of the same. And then just 384 minus 3 is obviously 381. Now solve it for x, obviously divide by the 990. Now they haven't said to simplify it, so in this case you could just leave it like that. It does simplify though, so just double check if they mention that they want you to simplify it or not. In this case they haven't written that. But if you wanted to know, the simplified version is 127 over 330, so if you got that, that would also be accepted. Question number 15. Prove algebraically that the sum of the squares of an odd number and an even number is always one more than a multiple of 4. Now this is a mouthful, right? First of all, when I've got algebraic proof, most of the time, depending on the question, but most of the time I try and split it into three things. First of all, what am I starting with? If they haven't already given you some kind of algebra, where is my starting point? That's normally the type of number they've asked for. So in this case, they've asked for an odd number and an even number. Now, obviously not just any, you can't just choose a number, you have to actually do it algebraically. So just remember this, the algebraic version or definition of an odd number is 2n plus 1. The reason being is because 2 times anything will make it even, won't it? Any multiple of 2 is even. If I then add 1 to any even number, it becomes odd, doesn't it? Because the consecutive number is odd. And obviously, based on that, then 2n is my even number, isn't it? So any version of this, 2n, 2n plus 1, or anything like this, where 1 is, obviously a multiple of 2, or a multiple of an even number, and the other one is a multiple of an even number plus or minus 1, or plus or minus some kind of odd number. That's step 1. Step 2 is then, what was the calculation? In this case, they want us to do the sum of the squares. Sum meaning plus, and then the squares, obviously, when you square it. So that means square this, and add them. Now, I'm still not even worried about what I'm trying to prove. Let me now expand and simplify this. Normally, it's a lot of expanding and simplifying. Just remember this first one here is double brackets, not just 2n squared and 1 squared, it's double brackets. Plus this one squared, which is 4n squared, not just the n squared, but 4n squared. So expand this, we get 4n squared plus 2n plus another 2n plus 1. Just be careful at the end, it is not 2, it is 1. Plus the other 4n squared. Collect the like terms. 8n squared plus 4n plus 1. Now, I've not even proved anything, but I would probably get 2 out of 3 marks for that. So don't even stress about what you're proving until the end. Now, as you can imagine, we're on step 3. Step 3 is, what am I trying to prove? 1 more than a multiple of 4. Normally, most of the time, right, algebraic proof is factorising something. So, in this case, I need to factorise a multiple of 4. That means I need to pull out, as my common factor, 4. And then it has said 1 more. So you can kind of see this plus 1. So I'm going to just partially factorise the first 2. I'm going to pull out 4. You just factorise it to, make it convenient to what you're actually trying to prove. That would be 2n squared plus n. And then do you see how there's still a plus 1? Well, this bit, it doesn't matter what's in the brackets, because if I then multiply by 4, whatever is in the brackets times by 4 is a multiple of 4, just by definition, isn't it? And then do you see how this bit is then, if that's a multiple of 4 and I've added 1, that's 1 more than a multiple of 4. So that's it, I've proved it. And I've proved it algebraically because whatever number I sub in for n, it will work. So don't ever try and sub in random numbers yourself. Okay, question 16, we've now got the diagram shows a solid shape. The shape is a cone on top of a hemisphere. Now, cones, hemispheres are not prisms, hence why they've given us the relevant formulas in the question. The base of the cone has a diameter of 8 centimeters. The hemisphere obviously also has a diameter of 8 centimeters. The total volume of the shape is 96 pi centimeters cubed. Work out the height, h, of the cone. They've basically given us the formulas for the volumes, and then they've given us the answer, right? So we just need to create an equation. Now there's 2 things that we need to be careful of here though. 1, for Edexcel particularly, normally they will give you the formula for the whole sphere. We obviously only have half. So we would need to remember to divide that by 2. The other thing is kind of similar. In both of our formulas we've got r, obviously for the radius, but they've given us the diameter. So we'd have to also half that. Sometimes I like to draw it on my diagram just to remind me. That would obviously be 4. So now I can set up my equation. So we've got the volume of the cone, which is 1/3 pi. The radius is 4, not 8 squared. And then h is what I don't know. That's what I'm trying to find out. So leave that in terms of h. Plus then the hemisphere, which is the whole sphere. But then I have to half it. Now that equals, I can actually make that into an equation, 96 pi. Okay, so I can set up that equation. Now I'm just basically solving it. I just want to find h. The first thing I would do is, you see how all 3 terms have pi, so you can just cancel that out. If it's non-calculated, they won't make you work out the pi. So get rid of that initially. Now let's have a look at this first one. 4 squared is 16 times 1/3. As I said, if you're multiplying a whole number by a fraction, you put it in the numerator, so that's 16/3. Because I'm obviously not going to work that out as a decimal, leave it as a fraction. Now this one over here, you can do it in multiple different ways. I would probably simplify this fraction. So you've got 4/3 divided by 2. That would make it 4/6, which simplifies to 2/3. So that's 2/3, and then we've got 4 cubed, which you should know is 64. However you want to work that out, in whichever order is fine. 96 is still there. So 16/3 h plus, again I'm going to multiply the numerator, 128/3. That doesn't simplify, so I have to leave it like that. Now, what I would do is I would just multiply everything by 3, because then that would cancel out my denominators. So I'd get 16h plus 128, and then all you'd have to do is work out 93 times 3. So that's 300 minus 12, which is 288. Now I'm obviously just going to solve it like a normal linear equation. So I'm going to subtract the 128 to get 160. And then just divide by 16, which luckily is quite a nice number. So h is 10. The height is 10. Now, that was actually 4 marks on the next page. They gave you a bit of extra space. So question 17, y is inversely proportional to x cubed. We've been given our matching pair of y and x values, and then we've been asked a question. Normally with proportion, if it's laid out quite nicely like this, I like to do it in 3 steps. And as you can see, we've got 3 sentences, so follow that. Step 1 is to write out the relevant equation formula. In this case, inverse proportion is normally y is equal to k over x, but in this case, because it's x cubed, obviously I'm going to copy that. That's literally step 1. Step 2, you use your matching pair here to find out the value of k. So 15 over 2 is equal to k over 2 cubed, which is 8. Now I just need to solve this. I'm always going to times by 8. Again, you can solve this however you want. It's effectively 15 times 4, so that's 60. Then I just rewrite my equation before I even try and answer the question. Just rewrite it, rewrite your formula. So in this case, 60 is k over x cubed. Step 3 is now to actually check what the question was. So find the value of x when y is 20 over 9, so I can just sub that in, right? So 20 over 9 is equal to 60 over x cubed. Now I just need to work out x cubed. Now, when you're trying to solve something, you can actually move the letter itself. In this case, you need to multiply. I would actually cross multiply, but I need to move the x cubed out of the denominator, don't I? So that would be 20x cubed is equal to 60 times 9, so 6 times 9 is 54 plus a 0. By 40, I would probably just knock off the zeros, just immediately deal with that, it's a bit easier. And obviously divide by 2, 27. Now they're not going to make you cube root or square root anything that is not already a cube or square number, so you should be able to recognize this is 3 cubed, so I can cube root. My answer is 3. Question 18, we've got ax to the power of n, and then all of that to the power of 2/3 is the same thing or is equal to 16x to the power of 4. Work out the value of a and the value of n. So, first of all, I need to effectively expand these brackets or apply that third index law, which is where you multiply the powers. Now, not only am I multiplying the n by the 2/3, but also the a is technically to the power of 1. So that would be a to the power of 2/3, not multiplied by 2/3, but to the power of 2/3. And then x to the power of, and then if you just multiply it by n, you've got 2n over 3. That equals 16x to the power of 4. Now, because we're trying to find out 2 letters, we need to separate it into 2 equations. Do you see how the a is technically just a constant, as in a number, so that would be equal to the 16. And that's separate to the x term, isn't it? This x term must be equal to x to the power of 4. So I'm going to look at them separately, okay? So I've got a to the power of 2/3 is 16 as one equation. And then x to the power of 2n over 3 is the same as equal to x to the power of 4. So that's my second equation. So this one's a bit more complicated, but just think about, how do I translate my power of 2/3? Well, the denominator is the root, so that's the cube root of a. And then the numerator you just apply as normal, so that's squared. So do you see how now I could reverse this? So I'm going to square root both sides. Again, they won't make you square root something that's not a square number, so that's obviously 4. And then cube both sides to get back to a. So a is 64. So that's one of them. Now the second one, this was kind of similar to the equation I started in our other indices questions at the start. If I've got x to the power of something equals x to the power of something else, then those 2 powers must also be equal. So 2n over 3, I can just separate that, is equal to 4, and then that's just linear, isn't it? Just solve that. So times by 3, 12, divide by 2, 6. That one's fairly straightforward. Question 19, we've got simplifying this algebraic fraction. So when you want to simplify it, you want to try and factorize as much as possible. There are 2 ways to do this, so as long as we get the same answer, it doesn't really matter which method you figured out first. So you could either already identify that all of them are multiples of 2, so you could divide the whole fraction by 2 initially if you wanted to. I would probably just factorize it normally, I guess. It doesn't really matter. So 2x and x times into make 30, 5 and 6, and then I want minus, that would make minus 10 plus 6 minus 4. And then in the denominator, this one often comes up, it will come up at some point in any of the papers, but often, I guess, within this topic, is difference 2 squares. Now, I am actually going to factorise out the 4 first. Hopefully it leaves it a bit more obvious. That is difference of 2 squares. You need to know how to factorise that because it can pretty much guarantee it will come up at some point, whether it's in this topic, whether it's just on its own or in another topic, I don't know. But it will pretty much always come up. And it's so simple to factorise. You just do both square roots, so x and 3, and then you plus and minus. Now, initially you're seeing, well, I don't see any brackets that are identical. That's because technically this 2x plus 6, we could also factorise out a 2, couldn't we? So that's what I was saying. You might have done that at the start, which is fine. That leaves me with x plus 3 And then do you see how now we've got two brackets with x plus 3? Cancel, cancel. The other thing we can also cancel is 2 divided by 4. That would simplify to technically a half, so the 2 would cancel. The 4 would become kind of left over 2, wouldn't it? So my answer would be x minus 5 at the top, and you can expand it at the bottom if you want. You can leave it as it is. They haven't really, well, I didn't specify when I wrote the question. That would be my answer. I can't simplify anything else. Question 20, write 3 over root 6 minus 5 root 2 over root 2 minus root 3 in the form a plus b root c over 2, where a, b and c are integers. So when they say this, effectively, obviously we're going to make them into the same fraction, into a single fraction. But do you see how their denominator doesn't have a surd and these two do? So effectively it's just rationalising denominators. Now we do have the two different types of denominators, one where there's only one surd, one term, and one where there's two terms. So they do rationalise slightly differently. So the first one you have to multiply by just that surd. Obviously, whatever you do to the top of a fraction, you do the same to the bottom. And then separate to that. The second one is a little bit more complicated. You have to multiply effectively by the denominator, but you have to change the symbol. So actually it relates to that difference of two squares. When we expand it, it should cancel out the middle bits. So we can expand all of that, multiply all of that. That would be 3 root 6 over 6. Minus, now that numerator is effectively single brackets, isn't it? You can write it out like that if that helps. Just be careful of what you are multiplying. Whole numbers, surds, they don't mix. So that first one would be 5, and then root 2 times root 2 is root 4, which would cancel out, or just literally square root to become 2. And then 5 root 2 times root 3, so again still 5, but then that would be root 6, 2 times 3 is 6. Over, now this is effectively double brackets. Root 2 times root 2 we just said would cancel out to make 2. Root 2 times root 3 makes root 6 positive. Then we've got minus root 3 times root 2. So still root 6, but now negative. That's the whole point, because then if you add those, they will cancel. And finally, minus root 3 times root 3. So that would cancel out to make 3, but just be careful because it is a negative, isn't it? So do you see how the middle terms would cancel? And obviously the first term and last term have just made whole numbers anyway. So then this surd would simplify to root 6 over 2. Minus 10 plus 5 root 6, and then 2 minus 3, be really careful, that is negative 1. So we're getting closer. Now, you could obviously divide that by negative 1, change all the symbols, and it would no longer be a fraction. But given that we are, going to end up with a fraction, I would probably leave it like that and go, how do I get the common denominators? Obviously just make them both 2. In this case, I would probably just bring the negative out and make that a positive. So that would be root 6 over 2 is still the same. This becomes a positive. And then if I double everything, times everything by 2, obviously not the surd, just the whole numbers, we'd have a common denominator, so now I can add them. 20 plus, obviously this is technically 1 root 6, isn't it? So that'd be 11 root 6 over 2. Now have a look at what you've got. As the format, it was a plus b root c over 2, which is what we've got, isn't it? So there's nothing else I can simplify. That would just be your final answer for 4 marks. Question 21, we've obviously got circle theorems now. So they said the angle BAC is 38 degrees, which you can see, and also ADB is 74. Again, you can see that. A, B, C, and D are points on the circumference of a circle. EAF is the tangent to the circle at the point A, and BCE just happens to be a straight line. It's not a tangent, right? Work out the size of angle ABC, so that's this one here. So normally there's a couple of different ways to do circle theorem questions. It's not necessarily just one way. I obviously want to get my angles and kind of start working towards the left, right? Because that's my final answer there. So I'm thinking 74. If you ignore this line in the middle, this is a cyclic quadrilateral, isn't it? A, B, C, D is a cyclic quadrilateral, which means the opposite angles add up to 180. So I can write down that BCA is 180 minus 74. So take away 70 is 110 minus 4 is 106. So you see how I'm getting closer. And the way that I would relate that is because we've been told BCE is a straight line. So I could then work out the other side of that line, which then gets me inside this triangle here. So ACE is 180 minus 106, which is obviously then back to being 74. So now that I know this angle, could I possibly work out this angle and then just have a triangle at the end? That's what I'm thinking. I've used the 74. Now I'm obviously going to be looking at the 38. So because I've got a tangent, and then you see how I actually happen to have two triangles, but effectively if you've got a tangent that attaches to a triangle, which, you know, all the corners touch the circumference, that is alternate segment theorem. Now, technically based on that, if I know that this corner here is 106, ignore this other triangle, right? We're just looking at the second triangle. That would make all of that, so outside that, also 106. You can either do that, or you could work out this angle and it would be the same as that one. It doesn't matter whichever way you want to do it. If that's 106, you see how obviously EAF is a tangent. That means it's a straight line. So BAF, let's write that, is 106. That's due to alternate segment theorem. You don't have to explain it more than that. If they ask for reasons, just write down alternate segment theorem. So then CAE is just on a straight line, isn't it? 180 minus the 106 plus the 38. So that added together is 144. Take that away. Subtract 140 is 40, so 36. This is 36. However you worked that out, whether you use the triangle or the straight line, doesn't matter. Now all I need to do is my last triangle. So the actual one they wanted was AEC, which is then just 180 minus those other two, 36 and 74. So if I add that together, that makes 110, so 70. 70 is your final answer. And that was for 4 marks. Question 22, the functions f and g are such that f of x is ax plus b, so we don't know it, and then g of x is 2x minus 10, where a and b are constants. So they've then given us these two kind of equations effectively, and they've asked us to find the value of a and the value of b. If they give you enough information for two equations, whether it's literally written like this or whether it's in worded format, if there just seems to be two things that they tell you about, and then they ask you to work out two values, two letters, that is, obviously this is functions, but that is underneath very likely to be simultaneous equations. So I'm going to set up these equations. So I'm going to work out the composite function. So because they've given me a number, I'm actually just going to sub that straight in. So sub the 7 into g. 2 times 7 minus 10 is 14 minus 10, which is 4. And then sub that answer into f. I know we don't know f, so leave it, 4 times a, or a times 4. So 4a plus b. Now technically that equals to 10. So do you see how that's one equation, isn't it? I can't solve it as it is because it has two letters, so leave that there. Look at the other one. We've got the inverse function of g, but also a number. Now I do need to actually do the inverse first, and then I'll sub in the number. So the inverse function of g is what I want to find out. Now I normally just put y instead of the g, just for now. Some people like to swap the x and y initially. Some people like to do it at the end. I tend to do it at the end. It doesn't matter. So I'm going to make x the subject. So I'm going to add 10 and divide by 2. So then I'm going to now swap it, right? Because I obviously don't want to have y in my answer. So the inverse function of g is x plus 10 over 2. Now I can sub in my 4. So the inverse function of g of 4 plus 10 over 2. So that's 14 over 2, which is 7. Now that is equal to f of 2. So I also need to work that out. I'll just do that over here quickly. Sub in 2 for x would be 2a plus b, wouldn't it? So do you see how my second equation would be 2a plus b equals 7? And now I've clearly got just linear simultaneous equations. So the way I'm going to solve it, you can either do substitution or elimination. I'm going to do elimination because they have the same number of b's. Same sign, subtract. So 4a minus 2a is 2a. b minus b is obviously nothing, cancels out. 10 minus 7 is 3. Now do you see how I could solve just for a? A is 3 over 2, or 1.5. Now all I need to do is work out b, which is when you just sub it back into one of the original equations. I'm going to use the second one because it's just smaller. So 2 times 3 over 2 plus b is 7. Obviously 2 times 3 divided by 2. The 2's cancel, right? That's just 3, isn't it? 3 plus b is 7, and then obviously minus the 3, which is 4. And that's 5 marks, obviously, because we did a lot of functions at the start. So our final question we have here is a rectangle and a right angle triangle. They've obviously got their side lengths based in terms of x. The area of the rectangle is less than the area of the triangle. So that's our, not equation, but that's our inequality, isn't it? And then it says find a set of possible values of x. So set up the inequality and solve it, is what that's saying. So based on the context, the area of a rectangle is obviously length times width. So 2x minus 4 times x minus 2. and then that's less than, so make sure you get the right around, the area of the triangle, which is obviously base times height, but also remember, so x times x is x squared. You do half that, don't you? Divide it by 2, so don't forget that, because obviously the rectangle you don't. Now I've got this, I can almost forget about my context and just solve this for now. So I'm going to expand this side, I get 2x squared minus 4x plus 8 is less than x squared over 2, which I don't really want as fractions, so I'll probably multiply everything by 2 as well. Let's just actually collect our like terms first, minus 8x plus 8, and now I'm going to multiply across by 2, so that'll be 4x squared minus 16x plus 16 is x squared. Now because as you can see my highest power of x is obviously x squared, whatever I do it's going to be x squared. So because it's a quadratic I'm going to move everything to one side, but I'm going to choose specifically the side that keeps my x squared positive, so I'm going to move this 1x squared because then I would still have positive 3x squared. So that's how I choose which way to move left or right. Whichever side keeps x squared positive, because now when I go to solve this, I'm going to try and factorize, and I don't want to factorize a negative x squared, ideally. So let's see, 3x, x. We've obviously got 2 negatives, so that's quite nice. And now we're multiplying to make 16, adding to make 16 as well. So 4 and 4. Now, because it's a quadratic inequality, I normally just solve it equal to x, and then I'll bring the inequality back in at the end. So that would be x is 4/3. Or positive 4. Now it depends which way the inequality symbol faces, just memorize this. If it faces a 0, it means your answer will be in a range, as in x will be between the two numbers. If it faces the quadratic the other way, you would have 2 separate inequalities, but that's not the case in this one. Now the only other thing you have to consider though, before you put that as your answer, is the context. Again, come back to the context. We've got side lengths here. Are any of them invalid? Now sometimes you get a negative answer, in which case that number would obviously be invalid. In this case we did get 2 positive answers, but have a look at the rectangle. If I subbed in both 4/3 and 4, would they still end up being positive side lengths? So just double check that your numbers work for the context. So if I sub in 4, 2 times 4 minus 4 is 4, that's fine, it's still positive. 4 minus 2, that's 2, still positive. Obviously on the triangle it's fine. But the other one, 4/3. 2 times 4/3 minus 4, so that would be 8/3, and then make that something over 3, 12/3. See how that would be negative, wouldn't it? That'd be negative 4/3. So 4/3 is too small. So you just have to figure out in this case, this is why this is the last question on the paper, what is the smallest value x could be? And that's the value that would make the side length at least 0, if not higher. So the easiest one is probably to look at the x minus 2. X would have to be 2 or more, because anything smaller than 2, if I subtract 2, would make it negative, wouldn't it? The same here, if I sub in 2, 2 times 2 minus 4 is 0, so it has to be at least 2. 2 minus 2 is 0 for the other one. At least 2 or more, doesn't it? So just be careful with these ones that have a context, so my actual answer would have to be x has to be between, obviously being 2 would be 0, so it has to be more than 2, doesn't it? And then between 2 and 4. Okay, so just be careful of the context there. And that is obviously 5 marks. So that is everything on my GCSE Maths Predicted Paper 1, obviously higher tier non-calculator. As I mentioned before, this was written by me, just basically based on anything I've seen in the Edexcel past papers for the non-calculator paper. This is not to guarantee these topics will come up or other topics won't come up, so please make sure you do actually revise around this. Just use this as part of your revision. Feel free to check out any of the other resources on my channel. If you want to look at other past papers, I've been through those in live videos, which will be uploaded onto my channel as well. So thanks for watching this video. If you found it helpful, make sure to like and subscribe, and you can also download this predicted paper and the answers in the description below.